10.3, we're looking at ellipses. Write equations of ellipses in standard form and sketch ellipses. Use properties of ellipses to model and solve real-life problems, and then find eccentricities of ellipses. So another type of conic is an ellipse, and it's defined below. An ellipse is a set of all points x, y in a plane, the sum of whose distance from two distinct fixed points, which are the foci, is constant. So d1 plus d2 is constant. The line through the focus intersects the ellipses at 2 points, which are the vertices. The chord joining the vertices is the major axis here, and its midpoint is the center of the ellipse. The chord perpendicular to the major axis at the center is the minor axis of the ellipse. So notice that the vertices are here along the major axis. So when we have to find it, you'll know which ones to choose. Here's a standard equation of an ellipse. The standard form of the equation of ellipse with center HK and major and minor axis of lengths 2a and 2b respectively, where b is between 0 and a. So you have x minus h squared over a squared plus y minus k squared over b squared. That equals 1. Now that is when the major axis is horizontal. Then we have x minus h squared over b squared plus y minus k squared over a squared equals 1, and the minor axis is horizontal. So the only thing that's different between the two is the switching of the a and b. Another important formula is that the foci lies on the major axis, c units from the center. And so when we're working with ellipses, this is the equation that we're going to use. C squared equals a squared minus b squared. So that is specific to the ellipse. And so here are some pictures. So notice that the major axis is horizontal here. So that is 2 times a. So in order to find a, we just need to cut it in half. So the minor axis is 2 times b. So to find b, we just cut it in half, right? So the center to that, this is going to be called the covertice. And then for the a, it's the center to the vertice, or vertex, sorry. And then notice the major axis is vertical here, so 2b is now here on this side, and then 2a is going up and down. So notice that the a value is always the longest value here, and then b is smaller. So let's try it. We're going to find the standard equation of an ellipse, find the standard form of the equation of the ellipse with foci 0, 1, and 4, 1, and major axis length of 6. So let's start with graphing these pieces. So we know 0, 1 is one foci, and 4, 1 is the other, focus, 4, 1 here. And what we can find really quickly after graphing it is we can find the center. So remember, the foci lies on the major axis, c units from the center. So the center, you can see, is right here between the 2 points. And so C, so center, let's label the center first because we do need that. The center is 2, 1, and then we know the distance between the center to one of the focus is 2 units, so that is C. Then we also know that the major axis is length of 6. So remember, major axis, that formula is 2 times A. So for given 6, major axis is 6, so 6 equals 2a. Divide by 2, a equals 3. So this tells us where the vertices are of the ellipse. Now again, remember that the vertices are along the major axis, okay? So those are along the major axis. So it's going to be wider this way, which tells us this is a horizontal axis. So major axis is horizontal. Okay, and so that's important to know what equation we're using. Now we do know A is 3, we know C is 2, so we need to find B. So to find B, we're going to use that formula, C squared equals A squared minus B squared, and so we're just going to solve for B. So we have 2 squared equals 3 squared minus B squared. So this is 4 minus 9 equals negative B squared. So we get negative 5 equals negative B squared. Or this is just 5 equals b squared, or b equals the square root of 5. So that tells us b is square root of 5, which is a little over 2. It's like 2.2 something. So the minor vertices is 2 away. from the center. So here and here. And then so that'll help us get a better picture of what this ellipse looks like. Not a great picture, but there we go. Something like that. Okay, but our goal is to find what the equation is. So the major axis is horizontal, so we need to look at x minus h squared, and then over a squared plus y minus k squared, k squared over b squared equals 1. Now a is the one that's the longer value, so if it's horizontal, then it's going to go under the x. If it's vertical, then it's going to go under the y. So just to kind of help you with the formulas here. So let's plug in everything we know. We know that the center is h and k. So we have x minus 2 squared over a squared. So that's a is 3. And then plus y minus 1 squared over b squared. So it's square root of 5 squared, and it always equals 1. So then let's simplify this. So the answer is x minus 2 squared over 9 plus y minus 1 squared all over 5 equals 1. So here is the standard equation of an ellipse. So try this example here. Find the standard form of the equation of the ellipse with foci 2, 0, and 2, 6, and major axis length of 8. So trying this out, the center you would find is 2, 3, so hopefully we graphed it to help you out. And then therefore C equals 3 in this case. The major axis is 8, and so we divide it by 2, and we get A is 4. Then we solve for B. B is square root of 7. Now with the graph, you would see that the major axis is vertical, so we have to use the other formula, which x minus h squared over b squared plus y minus k squared over a squared equals 1. And so then you substitute everything you know, simplify it, and here is the equation.